Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test held in the month of March 2025. It is a rescheduled examination for Assam Center. In this video, we discuss the solution of a problem from the section Complex Analysis, which is related to the Identity Theorem or Uniqueness Theorem. This question is placed in part B, which is a multiple choice question. It carries 3 marks. The question ID is 706513. Further, this question is suitable for all these examinations. Right. The given question is for z is equal to x plus iy belongs to the set of complex numbers. Let f of z is equal to u of x comma y plus iv of x comma y. Define an entire function, that is fz is given to be an entire function to us. Consider the function g of z is equal to u of x comma minus y minus iv of x comma minus y for z is equal to x plus iy belongs to C. Suppose that v of x comma 0 is equal to 0 for all x belongs to R. That means v vanishes on the real axis. V of x comma y will be 0 on the real axis. So when y is 0, it becomes 0. Define E is equal to the set of all z belongs to C such that f of z is equal to g of z. Which of the following statements is true? We are given 4 options. Option 1, E is the real axis. Option 2, E is the imaginary axis. Option 3, E contains an open subset of C, but E not equal to C. Option 4, E is equal to C. Agreed? Let's now discuss the solution of the problem in detail. For z is equal to x plus iy belongs to C, we have the function f of z is equal to u of x comma y plus iv of x comma y. Given f of z is an entire function, that is, it is analytic on the whole of the complex plane. Given g of z is equal to u of x comma minus y minus iv of x comma minus y, where z is equal to x plus iy belongs to C. Now take f of z, write down f of z bar, that is, write down f of x minus iy. So you take f of z, wherever there is y, replace it by minus y. That will be equal to u of x comma minus y plus iv of x comma minus y. Now for this take a conjugate. Take the conjugate of whole of f of z bar. So f of z bar and its conjugate is equal to u of x comma minus y plus iv of x comma minus y whole conjugate. is equal to u of x comma minus y minus iv of x comma minus y. It is precisely g of z. So what we have, g of z is f z bar whole bar. Right. Now, this is what we have. Now recall, whenever f of z is an entire function, then f of z bar and its whole bar is also an entire function. First of all, results. So it results, this result is not for entire functions. For a given domain D, whenever f of z is analytic in D, f of z bar whole bar is also analytic in D. Now extending it, if you take C in the place of D, then you will get this result. It is known that f of z is an entire function, will imply f of z bar whole bar is also an entire function. Thus, g of z is also an entire function. Right. Things have become very clear now. Let's move to the next slide. Right. Given E is the set of all z belongs to C such that f of z is equal to g of z. We are also given V of x comma 0 is 0 for all x belongs to R. This is very crucial. Right. On the real axis, what do we have? Y is 0, thereby z is equal to x. So get into f of z, write f of x. So f of x is equal to, wherever there is y, you put the 0, that will be equal to u of x comma 0 plus iv of x comma 0. V of x comma 0 is 0 for all x belongs to R. Therefore, you will get u of x comma 0. And see what happens to g of x. G of x is also u of x comma 0 minus iv of x comma 0. Replace y by 0 in g of z. Then you will get g of x is equal to u of x comma 0. What do you find? What do you find? Thus, f of z is equal to g of z for all z belongs to R. For all z belongs to R. So that means f of z is equal to g of z for all z belongs to R. That means R is contained in E. So R is in E. E contains the whole of R. Agreed. Let h of z is equal to f of z minus g of z. And clearly h of z is an entire function because f and g both are entire functions. Their difference is also an entire function. Now h of z is equal to 0 for all z belongs to R. Why? Because f of z is equal to g of z for all z belongs to R. Their difference is also 0. So now let us recall our uniqueness theorem or identity theorem. If you have an analytic function in a domain D, and if Zn is a sequence of distinct points converging to a point Z naught in D, and if f vanishes at every element of the sequence for each n, then fz is identically equal to 0 throughout D. That means now h is an entire function. H vanishes on the whole of the real line with a limit point with limit points, because every point on the real axis is a limit point of the real line. So it has not one limit points. Every point on the real line is a limit point. But what we want is it vanishes on the real line and it has a limit point. That is sufficient for us. By identity theorem or uniqueness theorem, h of z is identically equal to 0 on the whole of C. That means f of z minus g of z is identically equal to 0 for all z belongs to C. That is f of z is equal to g of z for all z belongs to C. So what is your E? That means for every z belongs to C, f of z is equal to g of z. Therefore, E is precisely equal to C. Thus, E is equal to C. So it overrules, the option 4 is true, and it overrules all the options. You can verify. Very clear. When E is equal to C, the others will not happen. Therefore, the answer to this question is option 4. And this is the detailed discussion of the solution of the problem from the section complex analysis, which is based on uniqueness theorem, that is the identity theorem from complex analysis. And it is an application of that. And if you watch the patterns of the questions that have appeared in the previous years, there will be at least one question related to the uniqueness theorem or identity theorem. In one form or the other, it is coming. It's very important. So what to do? Study uniqueness theorem, identity theorem and their proofs, and work out all previous year's questions and make a good notes. That will be helpful for you for the revision before the examination. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, we will be meeting once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.